Today we are going to learn combination of cells. Combination of cells or voltage sources. Combination of cells or voltage sources. So suppose if there is a circuit and if there is a circuit and instead of battery instead of one battery you have two batteries, right? You have two batteries. Each battery has an EMF E and and their internal resistance R, and the external resistance is capital, right? So this is a series connection of cells. This is a series connection of cells. Now the the total voltage or total EMF, better, total EMF is equal to 2E. See, E plus E, 2E, they are in series, so they will be added, right? So the total voltage is 2E, and equivalent resistance is equal to, see, this is 2R, 2 small r in series, right? This R and this R in series, and this R, capital R, is also in series, right? So the equivalent resistance is capital R plus 2 into small r, plus 2 into small r. So now this circuit can be redrawn as this. So, and the value of this is 2E, and this is R plus 2R, right? And now this has become the EMF, not the EM, this is the voltage, the value of the voltage source. So what will be the value of I? I will be equal to 2E divided by R plus 2R, R plus 2R, right? So this is how a series combination of cells is done. Now instead of 2, there may be n number of batteries or cells connected in series, right? So what happens then, if there are n number of batteries or cells connected, each having E and R as their EMF and internal resistance respectively, then what will happen that instead of 2E, it will become, since there are n number of cells, it will become NE, and equivalent resistance, instead of R plus 2R, it will become R plus N into smaller, right? So your I will become NE by R plus N into R. Is this clear?
Yes, sir.
Now we will go for parallel combination of cells. Parallel combination of cells. Now, this is important. Why? Suppose I have taken three cells which are connected in parallel. The positive ends are connected to one and all the negatives are connected to one point. And there is an external resistance R. And there is an external resistance R. Each has EMF E and internal resistance smaller, E, smaller, E, smaller. Now, as you can see that the total EMF of this circuit, right, is total EMF is equal to E only, because they all are connected in parallel, right? Because they all are connected in parallel, so the total EMF is E volts only. But what about the equivalent resistance? Equivalent resistance. What happens to equivalent resistance? Three R's are in parallel, right? Three small R's are in parallel. So the equivalent resistance is this capital R. Now let me draw the circuit. See, these three R's are in parallel, but this R is in series with the combination of the parallel of these three R. So let me write it once, then you will understand. R plus small r parallel small r parallel small r. Did you understand what did I meant to say? Let me draw the circuit again, then it will be clear. This is capital R and this is 1E with an equivalent resistance of these three internal resistance. So if R in parallel, the equivalent resistance is R by 3 and the EMF equivalent EMF is E and this is R. So this circuit gets reduced to this circuit, right? So your final equivalent resistance is R plus R by 3. R plus R by 3. Not this R, this capital R is not in parallel with all these three R's. Understood? So now current, if I wish to find out the value of current, the current will be, I will be equal to E divided by R plus R by 3. I is equal to R plus R by 3. Now what happens if instead of 3 you have n number of cells connected in parallel? Then instead of this 3 it will be m. You have m number of connected in parallel, so only this 3 will change to m. I equals to E capital R plus small r by m, small r by m, where m is the number of cells connected in parallel, where where small m is the number of cells connected in parallel. Now we will go for mixed combination of cells. Mixed combination of cells. Now what happens in mixed combination of cells? In mixed combination of cells, there are n number of cells connected in parallel, n number of cells connected in parallel, connected in series, and m number connected in parallel. Like this, and there is an external resistance capital R. So what happens is there are n cells, sorry, n cells connected in series, right? And each branch there are m such branches, and there are m such branches, right? And there are m such branches, which means this is 1 2 3 4 5 6 up to n number of cells, and the number of branches is m. Suppose this is 1, this is 2 branch, third branch, and it goes on and it goes on, right? The branches continue to increase in up to m. So we can say that n number of cells are connected in series and m number of cells are connected in parallel. Understood? So what happens here? First we have to find out the total EMF. So what is the total EMF? Total EMF is equal to the number of cells connected in series, right? So there are n number of cells connected in series, so total EMF is n into E. Now we have to find the equivalent resistance. What is the equivalent resistance? See, equivalent resistance, n number of cells are in series, so the resistance of each branch is n into r, since they are in series, r plus r plus r plus r up to n, and there are, this is again nr, this is again nr. So right, so there are m number of nrs connected, right? So what will be the equivalent resistance? So the equivalent resistance of this circuit will be 1 by nr plus 1 by nr plus 1 by nr up to m, right? So it will be nr by m. It will be nr by m, number of cells in series by number of cells in parallel into r, plus capital R, plus capital R, because the circuit will again be reduced to this capital R with a voltage source with the internal resistance. The EMF is NE and the internal resistance is NR by M, and this is capital R. So what will be the value of I? What will be the value of I? I will be equal to NE divided by R plus NR by M, or better M N E divided by M into capital R plus N into small r. N into small r. So the next topic is condition for maximum current. Condition for maximum current through the external resistance. Through the external resistance. Right. Now we know that there are n number of cells connected in series and m number of cells connected in parallel, right? So what is the total number of cells? Total number of cells is equal to m into n, right? M into n number of cells, right? Okay. So what was our equation for I? It was equal to mn into e divided by m capital R plus n small r, right? Okay. Now this can be written as m n e and m r plus n r under root both whole square. Let me write it. uh, Under root mr minus nr whole square plus 2 under root mn capital R small r. Now this I will be maximum when this value is 0. This value is 0, right? Because for any other value this will be positive and I will be less than the value when under root mr minus under root nr whole square is equal to 0. So we get that under root mr minus under root nr is equal to 0. Right? So we can write m r is equal to n into small r, and r is equal to n r by m. Right? What was this? If you go back to the previous slide, this was equal to the equivalent resistance. This was equal to the equivalent resistance of the equivalent resistance of the internal resistances, right? Equivalent resistance of the internal resistances, right? So what do we get as the condition of maximum current? The maximum current will flow through the external resistance when it is equal to the equivalent resistance of the internal resistances of the cells that are connected in series and parallel, right? For example, if you have an external resistance of 5 ohm, right, and an internal resistance of 1 ohm. For example, let me say that you have capital R is equal to 5, and you have cells with you with internal resistance equal to 1 ohm, right? So you have, what you have to make? You have to make n by m is equal to 5. So R will be maximum when it is equal to 5, right? R is 1. R is 1. So n r by m is equal to 1, right? Sorry, is equal to 5. So R is 1. So what do you get? You can connect all these cells in parallel, sorry, all the cells in series, and n is equal to 5 if m is equal to 1. So what are the conditions that you get? So you get n number of cells connected in series and only one branch. Had this been R, instead of 5, had this been 10 and smaller remained 1, then what would have happened? Instead of 5, capital R is now 10 and this is 10. So you can get n by m is equal to 10. So what you could have done? You could have connected uh, 20. You could have take n is equal to 20 and m is equal to 2. You could have taken n is equal to 20, m is equal to 2. That means you should require 40 cells, and these 40 cells, 20 of them should be connected in series in two branches or in two rows. Understood?